Hello everyone. In this video, I will be showing you how to configure your MRS16 controller. First, we will want to connect to the device, enter our password, navigate to the control tab, and then open our controller configuration. Any changes made in our controller configuration will have to be written to the controller for those changes to take effect. If we were to open our Setpoints from this icon here, any changes made will immediately take effect in the controller. Once we open up our controller configuration, any set points changed here will have to be written to the controller for those to take effect. By selecting a set point, a description of that set point can be seen here. By selecting controller help, a more detailed description of that set point or function can be seen. You will notice that we have 3 set points for all of our basic power settings. These are used with the functions of alternative configuration 2 and alternative configuration 3. When alternative configuration 2 is activated, all of our number 2 power set points will be used. When we activate the function of alternative configuration 3, all of our number 3 power set points will be used. Controller I/O. This is where you can view and configure all the binary inputs, binary outputs, and analog inputs coming to the controller. To modify the function, simply drop down the box and select the function you would like to activate with that binary input. We can configure these inputs as being normally open or normally closed. Normally open meaning when continuity from the binary input to ground is provided, the input is activated as well as the function it is programmed for. With the contact type as normally closed, when continuity between the binary input and ground is broken, it activates that binary input and the function it is programmed for. If we would like to program this binary input as a custom protection, simply drop down the box, select a unconfigured binary input protection, enter the name of this protection, whether the contact is normally open or normally closed, the protection we want to activate with the activation of this input, the delay we want prior to this input becoming active, and if we want this protection to be active at all times or only when the engine is running. If the input or that function is not being used, simply set the function as not used. Binary outputs. Again, we can expand the function box and select the function we would like this binary output to activate on. Normally open, meaning that when this function is active, the output is closed. Or normally closed, meaning when the output function is active, the output will be open. The MRS16 has high side outputs, meaning when the output is activated, it will be supplying whatever the battery voltage to the controller is. Analog inputs. These are where we configure the analog inputs physically coming to our controller. By default, these will be assigned to the function of oil pressure, coolant temp, and fuel level. If you would like to monitor a different value than what's provided here, simply drop down the function as a non-configured analog protection. Name the value you're monitoring. How we want this value displayed in the history. Select the sensor that is wired to that input, the dimensions for the bar graph, and what protection or protections we want to protect off of this value. Once the protections are chosen, we can select the delay and the levels of those protections. If we want the protection to be active over or under limit, if we want to monitor a failed sensor, meaning that the characteristics, meaning that the signal from that sensor is out of limits of the configured sensor curve. And if we want to protect on this value at all times, or only when the engine is running. In our Sensors tab, this is where we can select a predefined sensor curve or create our own. If we were not using the VDO 10 bar, we can select Open, and we can view every predefined sensor curve we have on file. We have a file for all VDO and DATCON sensors. Simply select the sensor you are using and press Open. If you are using a sensor that we do not have a file for, select a Open non-configured general line, select the signal type of that sensor, assign it a sensor name, select the resolution and the dimension, and then we can add and remove points as needed. If the sensor is strictly linear, we only need to define the very first and last point of that sensor. If the sensor is not linear, more points will need to be added. If you would like to save this sensor curve to use later on, click the Save button, name the sensor curve to your liking. Once the sensor is created, we can go to our controller I/O and select the sensor that we just configured. In our Modules tab, this is where we can add and configure any plug-in modules, an ECU, or CAN modules we have in the system. Plug-in modules, this is where we will add and configure any input or output modules to the controller. So we can select our BIO8 card, determine the protection we want upon module failure, and if we want that failure added to the history. Once the module is added, we can select the I/O configuration of that card and configure. For this card, we can select binary input 1 as either an input or an output, and then expand the function as desired. To configure an ECU, select the ECU module, ensure that we are on ECU list IntelliLight 2015, select the ECU you would like to configure, determine your protection upon module failure. If you would like to ignore ECU lamps during pre-start, if we would like to add the module status to our history, and if we would like to disable after treatment support. To clarify this is not going to disable the after treatment support of the ECU. It is simply going to disable the ComAp controller from reading and displaying the after treatment values. Once the module is added, we can select our I/O configuration and determine the ECU inputs coming from that ECU. By default, these are going to be assigned as coolant temp and oil pressure. If your oil pressure and coolant temperature is coming from the ECU and not a wired analog input, we want to ensure that in our analog inputs to the controller, we have these functions set as not used. Here we can configure and add CAN modules. We will select the CAN module being used. Again, determine the protection upon module failure, the name of that module, if we would like screens automatically populated to monitor this device, and if we want its protection status shown in the history. Once the module is added, the picture here will show you what any corresponding jumper settings and CAN settings need to be set on that module for it to properly communicate to the controller. By selecting our I/O configuration, we can determine what each of those inputs or outputs will be activated from. If we were to add a second module, again, the picture will update to show you what the jumper settings and the CAN address of that module needs to be set to. Selecting the I/O configuration, we can configure all the analog inputs available to this module. So these can either be a function in the controller or a custom protection. And this tab is where we can modify our PLC. This window on the left shows all available PLC blocks, how many total are still available to use, and then on the left, how many are currently being used. To use this function block, simply drag and drop onto your PLC sheet. By highlighting the block and pressing F1, we can view a description of this PLC block. By double-clicking on the block, we can assign the function of this PLC block, and then we can expand here to determine what the input of that block will be. Whether that input will be an inverted signal, and if we want the output to be inverted. We can also bring inputs and outputs to this PLC block by double-clicking on an open input block, selecting what we would like the input as, and then connecting the input to the input of the PLC block. To designate an output, simply double-click on an open output, connect the block to the output, and then double-clicking on the output, we can determine if we want that PLC logic to activate a logical function in the controller, or if we want it to activate a physical output on the controller. Once that logical function or physical output is selected, connect that PLC logic to the function or the output you've chosen and press OK. In the Others tab, we can modify the initial screen that is shown on the controller. We can determine what languages are available in the controller. We can determine access levels per set point. And we can also password protect any PLC set point that is being used or command to the controller. Here we can determine what format will be displayed throughout the controller. The resolution of our power format. Here we can select our user Modbus table where we can define custom values. The default Modbus register map in the controller can be exported by navigating to our Tools tab and then generate a CFG image of our Modbus registers. I hope this video was helpful. If there's anything else we can help you with, you can contact US Technical Support by emailing support@comapllc.com or give us a call at 1-844-267-1226. Thank you.